Okay, so we go through the topic 3E, which is the last part of the chapter 3. So we learn from the questions now. Okay, so this is the mistakes. Well, there are state 2 mistakes of this apparatus setup. So the first one, you shouldn't put stopper at B lah, because you need to bubble through the what we call the gas through line motor. Then here you should open up to let the what we call the gas to come out. So you shouldn't put any stopper at B. Then it will make the test tube B to be closed. Then as more and more gas release, right, then this thing will be high pressure. Okay, now for that, after the apparatus setup is correct, calcium carbonate is heated up until the constant mass is obtained. What happened to the lime water? The lime water will turn cloudy. Okay, so the chemical equation will be the calcium carbonate. If you heat up, you become calcium oxide and carbon dioxide gas. Then now they have 1.5 gram calcium carbonate is used. They want to calculate the mass of the residue. This is the calcium oxide. So first thing we calculate how much calcium carbonate is used. So 1.5 gram is mass, so you use mass over molar mass to find. So the mass is 1.5. The molar mass is calcium is 40, carbon is 12. Then 3 times 16, you get the mass is 0.015. Then how much residue left? The residue you mentioned about is the calcium carbonate, because carbon dioxide is gas mass, so you fly to the sky. After that, the leftover, the residue will be the calcium oxide. So from the equation, 1 mole of CaCO3 will produce 1 mole of calcium oxide. So now you have 0.015 mole of calcium carbonate. You will produce 0.015 mole of calcium oxide also. Then after that, number of mole is equal to mass over mass. So 0.015, the calcium oxide will be 40 plus 16. You'll get the mass equals to 0.84. Then how much gas released? So same thing now, from the equation, 1 mole produce 1 mole of carbon dioxide gas, 0.015 produce 0.015 of carbon dioxide gas. So you convert the volume, so 0.015 times the volume, molar volume is 24, you'll get the volume is 0.36 dm cube. Okay, when you try this one, the carbon is 14.4 gram, hydrogen is 2.4 gram, so divide by 12, divide by 1, you'll get 1.2 mole and 2.4 mole. Divide by small number, both divide by 1.2. So you get one ratio is 1 to 2. So the empirical formula is CH2. Then the relative molecular mass is 70. So what should we do is the bracket N is equal to 70, because empirical formula is CH2, then molecular formula is CH2 bracket N. Then bracket N equals to 70 because the mass is 70. So you put C equals to 12, then N equals to 2, you'll get N equals to 5. They put inside back the 5 into the N, then you get C5H10. Zinc nitrate decompose and heat strongly. So zinc is the N2 plus, nitrate is NO3 minus. So you get Zn bracket NO3 bracket 2. Then you produce zinc oxide. So you get zinc oxide plus nitrogen dioxide and oxygen. Okay, balance this equation. When you try to balance, right, the N you put into 2 here, you're stuck at the middle, because here got 1 O, here got 4 O, here got 2 O, total got 7 O, here got 6 O. So technically you are stuck. So when you start, I told before, you find the longest one times 2. So the longest one will be this 2. So 2 is the N. Then N times 2 will be 4N. Then the oxygen will be 3 times 2, 6 times 2 will be 12. So here will be 2 plus 8 plus 2, total will be 12 or so. Okay, so it's balanced today. What is the mass when 18.9 gram of zinc nitrate is heated? So first I use mass over molar mass to find the moles. I get 0.1 mole. Then I want to find the mass of zinc nitrate. So you look at the relationship of 2 mole produce 2 mole. So you can write from the equation, 2 mole of zinc nitrate produce 2 mole of zinc oxide. Therefore, 0.1 mole produce 0.1 mole of zinc oxide. Then from there, you change to the zinc oxide. So I get 0.1 mole zinc oxide. So I put in 0.1 mole zinc oxide. From there, I was able to find my mass equals to 8.1 gram. So what's the total volume of gas release? Okay, total volume of gas release, I got total 4 plus 1 now. So from the equation, 2 mole will produce 5 mole of gas because 4 mole NO2 and 1 mole O2. So now I have 0.1 mole, I'll get 0.25 because 2 to 5 is you take 0.1 divided by 2, then times 5, you get 0.25. Then also once you have 0.25 ID, from there you start to times in to get the 6 dm cube. Then to convert to the particle, we just need to 0.25, then times 6.02, you'll get how many particle of the gas release. Ammonium sulfate, okay, this is to find the fertilizer. So to find the fertilizer, right, first you need to find the mass of nitrogen divided by total mass. So you can see the nitrogen divided by total mass in your ammonium sulfate, then you're able to find the percentage. Using the same tactic, you find the percentage. You found that percentage, this is higher. So it will be the better fertilizer because the nitrogen fertilizer is right nitrogen. The more nitrogen you have inside, it will be a better fertilizer. The chemist suggests another fertilizer which might be better called urea. So we'll check the urea percentage. I'll get 46.67%, even better. So it's the best fertilizer. Then this is the same thing. Ammonium carbonate, aluminum carbonate. If you hit aluminum, is 3 plus. CO3 is 2 minus. So you get Al2 bracket CO3 bracket 3. And heat already will become aluminum oxide. Aluminum is 3 plus, O is 2 minus, plus carbon dioxide gas. And you try to balance this equation. Yep, put a 3 here, is balanced. Okay, so I have 0.5 gram of aluminum carbonate. So firstly, I convert this to number of mole first. 0.5 divided by aluminum carbonate, I will get 0.021 mole of aluminum carbonate. Then from the equation, I want to find the gas release. 1 mole will produce 3 mole. So write the equation up. From the equation, 1 mole of this thing will produce 3 mole. Okay, therefore, 0.021 will produce 0.063. Then once you have this already, you can start to find the volume. Use a volume over molar volume. Put in the 0.063 inside. You get the volume equals to 0.1512. Then you go through this one. Relative mass of this thing is 34. So what is the meaning of this thing? One mass of one molecule of this chemical is 34 times heavier than 1/12 of carbon. So this is one of the potential question I might ask you. So what is the volume of oxygen needed to burn this thing? So now I have this is 48 dm cube. So first use that to find number of mole first. I will get 2 mole. Then look at the ratio, the one volume oxygen gas ratio. Oxygen gas is 4 to 8. So times 2, so 2 mole will get 4 mole. Then from there, you get your volume, the 4 mole, you bring over here, you'll get your volume will equal to 96. Then this much of X react with this much of Y for this compound called X2Y3. So put the mass first. The ratio is 2 to 3. Then you given this thing is X is equals to 27. So 22.7 divided by 27, you get 0.1. Then you divide by 2 times 3. You get this ratio, the mole should be 0.15. Then 2.4 divided by Y, unknown math. So you divide by Y. So you get this number. Then from this number, you try to find out your Y will equals to 16. So the relative mass will equals to 16. What is the percentage of the carbon in this thing? So you take the carbon mass, which is 6 carbon, 6 times 12, divided by total mass, 6 times 12 plus 14 times 1. You get a percentage is 86.01%. Then a group of students conduct an experiment to study the decomposition of the magnesium nitrate. So this is the chemical equation. It is found is incorrect. Find out the answer why. First thing, this is not balanced. Then if we try to balance, here, it's the same concept that if you try to balance the N, is stuck there because you got 1 oxygen, 4 oxygen, and 2 oxygen. Total, we have 7 oxygen. But here only got 6, so it's stuck here. In order to solve this thing, we have to find the biggest one times 2. So 2 mg. Then N, I have 2 times 2 is 4. Oxygen, we have 3 times 2, 6 times 2 is 12. So here got 2, here got 8, here got 2, also 12. So the balance equation will equal to 224. Based on the equation, give me 3 information. So first information, the reactant is your magnesium nitrate. The product is your magnesium oxide, nitrogen dioxide gas, and oxygen gas. And then this is the ratio. 2 mole will decompose to form 2 more magnesium oxide, 4 more nitrogen dioxide gas, and 1 more oxygen gas. Then 5 grams of magnesium nitrate decomposed, calculate the mass. Okay, so we look at the ratio here. We have 5 mole. So first thing, change your mole to number of moles. Then look at the ratio. I want magnesium. So the ratio is 2 to 2. So write the sentence. 2 mole produce 2 mole. So 0.0338 will produce 0.0338. Then convert the 0.0338 to number of mole. Then you'll get your mass equals to this thing. Write a balance equation for this. Let me check. Calcium carbonate, rare hydrochloric acid. So calcium carbonate, rare hydrochloric acid. For this one, it's supposed to give you the product. So CaCl2, you can write down first, H2O. It's supposed to tell you the product is calcium chloride and H2O. Because in the Form 4 first term exam, you no need to know these 2 chemical react will produce what product. Okay. So calculate the mass of calcium carbonate used. So you check here. The volume of gas released, they hide inside here, which is 50 cm cube. So first thing you must mention about the 50 cm cube. 50 cm cube is equals to 0.0 divided by 1000 dm cube. So you take the 0.05 divided by 24, you get the mole equals to the 0.021. Then look at the ratio of carbon dioxide gas and calcium carbonate is 1 to 1. So 1 mole produced by 1 mole, so 0.021 produced by 0.21. From there, you're able to put in your 0.021 of calcium carbonate to find your mass. You get a mass equals to 0.21 gram.